Okay, it's time to go over the Unit 3 Lesson 2 classwork. Okay, we have QRS is triangle QRS is similar to triangle TUV. How alphabetical of it. All right, first we'll make a proportionality statement. And I'm just going to do it with the letters based on the similarity statement. QR, RS, and QS. And those will be proportional with TU, UV, and then TV. All right, it says given the similar figure, set up a proportion, then solve for the given variable. So here's our proportion. We just have to fill it out. There will probably be a part of this proportionality statement that we won't end up using. I believe it's going to be the last part because we don't know QS and we don't know TV. They're not listed, but we can at least set up the first half. QR is 24 and TU is x plus 5. And that will equal RS, which is 54, over UV, which is 36. Now, one of these is the scale factor. 54 over 36 can reduce to the scale factor. In its current state, it still is the scale factor, but it's easier to work with if we reduce it. So I'm going to do that. I'm going to reduce it to 3 over 2. 18 goes into both of those numbers. 24 over x plus 5. And then when you have an expression in a fraction, make sure you put parentheses around it. Okay, we can find the cross product here. So 2 times 24 equals 3 times x plus 5. And 2 times 24 is 48. And then distribute the 3 to each of these. 3x plus 15. 48 minus 15 is 33. And then divide both sides by 3. You get x equals 11. Now, if we wanted to, we could put the 11 back in and figure out what that side length is. It would be 11 plus 5, which would be 16. So that side length would be 16. And remember, our scale factor was 3 over 2. Now, a lot of people have a hard time at first picking out what triangles there actually are in this diagram. And I'm going to highlight those now. This is one triangle, ADE. And then the other triangle is ABC, and that's the bigger one. So you can think of it as a triangle on top of another triangle, or a triangle inside of another triangle, but there's a lot of corresponding sides that are on top of each other. And we know that they are similar. So I am going to make a proportionality statement. So AB, BC, and AC. And then AD, DE, and AE. And I will fill out as much information as I can. But let's start off with AB. We don't know explicitly what AB is, but we can use the segment addition postulate in order to add these two together, 20 and 8. And that would make AB 28. And AD is 20. And then ABC is 2x plus 3. And DE is 15. And we actually don't know anything about AC or AE, so we can just stick with that proportion. 28 over 20, we can clearly reduce to 7 over 5. And then 2 x plus 3. I'm going to put parentheses around that, and then 15. We could find the cross product on this one, but I'm actually going to just multiply 7/5 times 3, because I know 5, here I'll do it in a different color, 5 times 3 gives me 15. 7 times 3 will give me 2x plus 3, so 7 times 3 is 21. So 2x plus 3 equals 21. 2x will equal 18, and x will equal 9. Now, if we were to put this back in, it would be 18, 2 times 9, which is 18, and 18 plus 3, which is 21. This whole BC would be 21. And that's fine, but what we really needed to find was x equals 9, and our scale factor was 7/5. That's the larger ABC to ADE. Ooh, bow tie problem. Sometimes with these, it's difficult to match up which side goes with which, so that's why it's really important that before you even look at the diagram, you can make a proportionality statement. MN, NP, and MP, and on the bottom, I'll put QR, RP, and QP. Now in this one, we're not going to use MN and QR. It's just not, we don't know anything about those sides, so we're just not going to use that. But we will use the other two as our proportionality statement. NP is x plus 8. RP is 3x minus 9. And that equals MP, which is 24, over QP, which is 28. And 24 over 28 reduces to 6/7 if you divide the top and bottom by 4. We'll make those numbers as small as possible because we're going to have a lot of distribution to do here. Three x minus 9. Okay, so let's find the cross product. 7 times x plus 8 equals 6 times 3x minus 9. 7x plus 56 equals 18x minus 54. Holy smokes. Doing some nice algebra on this problem. Okay, I'll subtract 7 from both sides, and that leaves me with 11x. And I'll add 54 to both sides, which that is 110. And 11 divided by 110 divided by 11 is 10. So x will equal 10. Now, if we put this back into these problems, NP would be 10 plus 8, which is 18. And PR would be 3 times 10, 30, minus 9, which is 21. But we don't have to put it back in. We just need to know that x equals 10. Moving on. Two triangles. We don't have to worry about matching up the sides because the similarity statement is given to us. I'll write my proportionality statement. Once again, we're not going to use part of this. We're actually not going to use the CDGE part. We don't know anything about those side lengths, but we will fill out the rest of it and set it equal to itself. So BC is 39. FG is 4x plus 2. And that equals BD, which is 42, and FE, which is 5x minus 2. All right, these are going to be some large numbers for our cross product. 39 times 5x minus 2 equals 42 times 4x plus 2. And distributing, 39 times 5x is 195x. 39 times negative 2 is minus 78. And distributing the right side, 42 times 4x is 168x, and 42 times 2 is 84. Okay, let's collect like terms. So I'm going to move the 168 over to the other side and subtract it. That will keep my x variable, x coefficient positive, and 195x minus 168x is 27x. And then 84 plus 78 is 162, and that divided by 27 is 6. Now, if we wanted to, we could put this back in and figure out the lengths of the other sides. 5 times 6 is 30. 30 minus 2 is 28. And 4 times 6 is 24. And 24 plus 2 is 26. But we didn't have to do that. We just needed to find out what x was. All right, KLMN is similar to PQRS. This is a big similarity statement we can, proportionality statement, I mean, that we can write, and I'm going to do that. KL, LM, MN, and KN. And we don't have a lot of information in this diagram, so we're not going to fill out all of these fractions, but we'll fill out what we can. And that matches up with PQ, QR, RS, and PS. They equal each other. All right, let's fill out the ones that we know. We don't know what KL is. We don't know what MN is. We don't know what PQ is. And we don't know what RS is. So we're going to fill out LM, QR, PQ, KN and PS. So LM is 4x plus 4, and QR is 48. And that equals KN, which is 7x minus 9, over PS, which is 60. Another one with a large value, 60 times 4x plus 4 equals 48 times 7x minus 9. $240x plus 240 equals 48 times 7, which is 336x minus 48 times 9, 432. All right, let's get the x's together. And I'm going to try to make them positive. Negative 240x, negative 240x. And that's 96. Ooh. Sorry, so that got weird. 96x, and then I'll add 432 to both sides. That will put the numbers that don't have a variable on the other side. So 432 plus 240 is 672. Such big numbers. All right, 672 divided by 96 is 7. So x equals 7. We can write that in here. Whoa. Got a little fishy. X equals 7. Now, if we wanted to, we could figure out what LM and KN are. I'll let you do that, though. That could be something that you do for yourself. Oh, these are tough to line up sometimes, but luckily we have a similarity statement, and we don't have to worry about lining these up by I. We can line them up by the similarity statement. So RS, ST, and RT. And then we have YS, SZ, and YZ. Yikes. And these all equal each other. And we don't know what YS is, and we don't know what RS is. And we can't figure them out. So we're just not gonna deal with that part. We're gonna fill out the rest of this. ST is 40. This is it. Big on the side, it goes all the way to the end. SZ is going to be, well, ZT is 5, so SZ will be 40 minus 5, which is 35. And then we have RT, which is 3x minus 7, and YZ, which is 2x plus 2. And we should be able to reduce the left-hand side here. 40 over 35 reduces to 8 over 7 if you divide it by 5. I'll keep our numbers a little bit smaller. But we are going to have to solve this proportion, and it will be 8 times 2x plus 2, and that equals 7 times 3x minus 7. Distribute. 16x plus 16 equals 21x minus 49. I will put my x's on the right-hand side, adding the opposite, so I'm going to subtract. 21 minus 16 is 5x, and then I'm going to add 49 to both sides. And that's 65. And 65 divided by 5 is 13. X equals 13. And that would be 28 if we put it in for YZ, and 32 if we put it in for RT. But we didn't need to do that. We just needed to say that X equals 13 in this problem. Great. Well, I hope you were able to follow along. Those proportions were fairly challenging. Makes sense why in our last unit we did a lot of challenging proportions and included them on the quizzes and tests. It was to get you ready for this. We were able to solve all of these, which is a pretty great thing. I was able to find the scale factors of almost all of them. And if I wanted to, I could have found it on number 5 and number 4. I would just have to reorient my proportions a little bit once I set them up. But not bad. All right. Thank you.